Okay, can you guys see it?
Yep.
Yeah, okay. Hey everybody, my name is Ethan and my group mates are Azlan and Jayden. And our project was about object detection for self-driving cars. So here's a brief overview of what we're going to go over in this presentation. Okay, and now Azlan will be now Azlan will start us off with the introduction.
Hello. So we're going to go through a quick introduction of object detection in autonomous vehicles. Object detection refers to the use of computer vision to try and identify the objects in an image. This can show up in multiple forms, but by far the most successful forms of object detection are self-driving vehicles, facial recognition, and the analysis of medical records. So, autonomous vehicles use object detection to see which things are in their path and drive accordingly. So, this means that object detection is just one of the AI used in self driving. The reason autonomous vehicles have recently gained such a massive surge in popularity is because as time has moved forward, the time that people use to drive cars has gone up, with it being around 6% of the time that Americans use in their life. And so there are a lot more benefits to them as well. For example, self-driving cars can reduce traffic because they will be able to both use the space of roads more efficiently, and they will drive safer than human drivers can. So now we're going to move on to Ethan, who will be talking about the classification of our project.
Okay, so I'm gonna give a brief explanation of the data we used for this model. The data we used was from the CFAR 10 dataset. We included three types of images, which were backgrounds, cars, and trucks. The training data consists of 15,000 images, 5,000 images for each category, and the testing data consists of 5,000 images. We tried a total of three training models. The first one is a multi-layer perceptron, or MLP in short. An MLP functions like a typical neural network, where inputs will be evaluated by hidden layers in the model, resulting in a prediction or a classification. In our model, the three inputs will be images of either a background, a car, or a truck. The hidden layer consists of 128 neurons activated by the ReLU function. The model then produces the three outputs based on whether it thinks the image is a background, a car, or a truck. And the training accuracy of our data was approximately 87%, and the validation accuracy was around 72%. As you can see, there is a bit of overfitting happening in our model. So the second model we used was a convolutional neural network. The CNN model basically breaks down the image into smaller components and analyzes whether each pixel is relevant to the prediction. An advantage of using a CNN will be that it can generate an accurate prediction regardless of the object's location in the image, since every single pixel is examined and taken into account through a technique called max pooling. This resulted in a training accuracy of 99.96% and a validation accuracy of around 85.33%. Again, the model is a bit overfitted, but still performed better than the MLP model. And even though the previous models performed decently in training and testing, the improvement was not as apparent as that of our transfer learning model. Transfer learning basically means that a model is gaining knowledge and refining its algorithm every single time it performs a prediction or a task. And with that, it is able to build onto its pre-existing knowledge or data in order to make accurate predictions. And the transfer learning model performed the best out of the three with a final training accuracy of 98.55% and a validation accuracy of 94.1%.
So now I'll be talking about localization. Localization is the process of identifying specific positions of an object, feature, or event with given input. In our case, localization was used to identify an object within an image or a video. So one technique is called the sliding window. And sliding window technique is having a fixed size window that slides through the image while it crops it and analyzes the images one by one. The advantage of this algorithm is that it is easy to implement many simple classifiers and traditional computer vision techniques. However, it comes with various disadvantages too. The sliding window algorithm requires scanning the entire image at multiple scales. which leads to a large number of windows to evaluate. If the image we have to process is big, more computational power will be required to process these images, which is significantly inefficient compared to other modern alternatives. Another alternative is a technique called YOLO. YOLO, or You Only Look Once, is a real-time object detection system that approaches object detection as a single regression problem, from the image pixels to bounding box coordinates and class probability. YOLO, developed by Joseph Redmond, is one of the popular object detection algorithms due to its speed and accuracy. There are many series of the YOLO model, and we have utilized the YOLO v3. Our method utilized a CNN known as darknet, which divides the input image into a grid of cells. With each cell directly predicting a bounding box and the object classification, the output consists of numerous candidate bounding boxes, which are then refined into the final prediction during the post-processing stage. With YOLO, we were able to analyze this image, which it clearly has done, and then we also analyzed the video. Now we'll move on to ethics by Azlan.
Okay, so there are many ethical considerations for self-driving vehicles. The biggest is whether or not the AI will malfunction when driving and either recognize an obstacle that isn't or maybe not recognize anything in front of it. So for this reason, most self-driving vehicles today either have a lot of permits involved, or they have or they have driver controls built in so that they can brake or swerve from any obstacles in their path. For this reason, most governmental agencies and companies such as Tesla, Google, and more need to receive tight permits when using self-driving vehicles, despite the advances that has been made in the field. So now we're going to move on to Ethan to talk about our conclusion.
Yeah, so in summary, the object detection model is capable of identifying and localizing a wide range of objects. It is an essential part in the development of autonomous vehicles and can be useful in many different ways. Thank you for listening.